Hey, hi, and welcome back. I hope that you're enjoying the testing and troubleshooting process. So, in previous video, we completed the testing of power supply section, and in this video, we are going to test the microcontroller section. Alright, so now let's start with this video. So now let me tell you what you're going to learn in this video. So again, the same point, which is testing and troubleshooting. So I'm going to discuss the detailed procedure to test and troubleshoot the microcontroller section. And after that, I'm going to show you the practical demonstration of microcontroller section. And during this demonstration, what we are going to do, we are actually going to program the controller, and that code will be written in such a way that the controller is actually going to send the data over the TX line of UART interface. Okay. And we are going to see that data on the terminal window on the computer. So controller will send the data to the computer, and we are going to check that data on the terminal window. Okay. So that's basically the point which we are going to cover in the practical demonstration. Then the next point is monitor TX pin of MCU on DSO. So again, in this particular point, the controller will be actually programmed with the same code. And what we are going to do, we are actually going to monitor the TX pin of UART interface, and we are going to connect the TX pin of UART interface to the DSO. And we will see the same data which we are sending on the terminal window, or the data that we are seeing on the terminal window. So we will see how exactly that data look like in terms of signal on the DSO. Okay. So we are going to monitor the TX pin, and the data which is sent over the TX pin, we are actually going to monitor it on DSO, and we will see how exactly that data look like. Okay. So this part is going to be a lot interesting, and I'm sure you will definitely enjoy this particular part. Then the next point is mistakes. So again, I will discuss the mistakes that you should avoid while dealing with the microcontroller section. Okay. And the mistakes that I'm going to discuss in this particular video, it's going to save you a lot of precious time. Okay. So listen to the mistakes that I will discuss in this particular video. Okay. So that's how basically we are going to cover this video, and I'm sure you will learn something valuable from this particular video, and you will enjoy this video. Okay. So now let's start with this video. Alright, so in previous video, we saw that the power supply section is working perfectly fine, and it's producing 5 volt on the output side as expected. Okay. So it actually means that all the peripherals which are working on 5 volt on this particular PCB, all the peripherals are actually getting 5 volt. Okay. Now, as we are testing this microcontroller section in this video, so what we will do, first of all, we will check whether the microcontroller pin or all the VCC pins which are present on this microcontroller are getting 5 volt or not. Okay. So that's basically the first thing that you have to check, when you deal with the microcontroller. So what I'm going to do, I'm going to bring the multimeter in the frame now. Alright, so we have the multimeter in the frame. Let me set the knob to voltage. So I have set it to 20 volt. And after that, I'm going to connect this negative terminal at this point. Okay. So I'm going to connect it to the ground, or this plus 5 volt, ground tab of this 7805. Or you can also connect this negative terminal of the multimeter to the power source. So I have the lab bench power supply, so I can connect this negative terminal there also. But let me connect this negative terminal at this point, and let's check whether 5 volt is available on all the pins of microcontroller or not. So at this point, we need the 5 volts. So let's check whether we have the 5 volt or not. So you can see 5 volt we are getting. So we actually have to check on the pin. So this is basically the 5 VCC pin of microcontroller, and you can see on the multimeter we are getting 5 volt. In the same way, this is actually another VCC pin. So I am checking, and you can see on the multimeter we are getting 5 volt. So there are actually 3 VCC pins on the microcontroller. So these were 2 VCC pins, and the third one is actually here. So I'm going to connect. So this is not the VCC pin. This one. Alright. So this is actually the VCC pin. And on the multimeter, you can see we are actually getting 5 volt. So it means that on all the VCC pins of this microcontroller, 5 volt is available, and this controller is actually powered properly. So this is actually the good sign, and it also means that everything is okay with the controller at this point in time. Okay. After that, let's check the reset section. So again, I will connect this negative terminal at this point. And let's check the reset point. So I will connect the multimeter at this point. And on the reset pin of microcontroller, you can see we are actually getting 4.98 volt. So you can also connect the directly on the reset pin of microcontroller. I'm connecting at this point. The reason is we know this particular track or this point is connected to the reset pin, so it's actually the same. So I'm going to tap this point, and you can see on the multimeter we are actually getting 4.98 volt on the reset pin. So it means that right now the reset pin is pulled to VCC with the help of this resistor which is of 10k value. Okay. And if I press this reset button, then you will find that you will actually get 0 volt on the multimeter. So I will do that now. So I'm going to press this button. So you can see we are actually getting 0 volt on the multimeter. Okay. Right now the controller is actually under the reset state. And if I release the button, so you can see again we are getting 4.9 volt. And if I press it again, you can see we are getting 0 volt. So reset pin or a reset button is actually working perfectly fine. So this actually ensures that. Alright, so we have checked everything from controller point of view. So you have to check whether the voltages are available on all the VCC pins or not. Then you have to check whether the reset pin is the voltage on the reset pin is 4.9 or 5 volt. And when you press the reset button, you are getting 0 volt on the reset pin or not. So this was all about the testing and troubleshooting of microcontroller section. And this actually gives us the idea that everything is perfectly fine with the microcontroller section. And now we can program the code in the microcontroller. Okay. So before we program the code in the microcontroller, first of all, let me place this multimeter aside. And what we are going to do. So now what we are going to do, we are actually going to connect the microcontroller with the external USB to TTL converter. And by connecting that USB to TTL converter to the computer, we are actually going to program the code in the microcontroller. Okay. So first of all, let me explain the connection on the screen. So that will actually give you a good idea about what exactly we are going to do. So first of all, we are going to program the code in this controller. And this controller is actually going to send some data over the TX pin of UART interface. And we are going to monitor that data on the computer screen. Okay. So that's basically the first point. And later, the second point is we are going to monitor the TX pin of microcontroller that is of UART interface on the DSO, and we will see how exactly the data which is coming out of TX pin look like. Okay. So now let me explain these connections on the screen, and from there you will get more clarity about how exactly we are connecting our hardware to the USB to TTL converter, and how exactly we are going to connect the hardware to the DSO. Okay. So now let's go to the screen and let me explain that now. So now let me discuss the setup to send the data from the microcontroller to the serial terminal. Okay. And the setup is very simple. We have three blocks in the setup. The first one is controller. Then the second block is USB to UART converter module. And then the third block is computer on which we are going to see the data. Okay. So this controller will be actually programmed with a code, and that code is actually responsible for sending the data on the UART interface TX pin. Okay. So we discussed that in the controller there is a UART interface, and that UART interface is going to have a TX pin, and over this particular TX pin the controller is actually going to send the data, and that data is actually nothing but the hello world. Okay. So the controller is actually sending hello world string over this TX pin. So this TX pin we have already connected to this debug header, and to this debug header we are actually connecting this USB to UART converter. Okay. So what we are going to do, we are going to connect this debug TX pin, which is basically the TX pin of controller. So this particular pin will be connected to the RX pin, which you can see here. I'm connecting this debug TX pin to the RX pin of this USB to UART converter, and again the ground pin will be connected to the ground pin. So we just need two pins to send the data from the controller to the computer. Okay, and that pin is TX pin and then the ground pin. The ground pin because we always send the data with respect to the ground. So ground will be common between this circuitry and this circuitry. Okay, so whenever you connect one circuitry, whenever you connect one circuit to another circuit, you have to always connect the ground, and later you can connect rest of the signal. Okay, So ground is going to be the reference point for both the circuitry. Okay. In the same way, in this particular circuitry, we are actually connecting this ground, the ground of our circuitry, and this particular ground, which is ground of this circuitry. Okay, USB to UART converter circuitry. So this ground will be connected here, and then the TX pin of the microcontroller will be connected to the RX pin of this USB to UART converter. And then this part of this cable will be connected here, and then this part will be connected to the USB port of your PC. Okay, so we can't actually connect this UART interface directly to the computer. It's because there is actually no serial port exposed on your computer, but you have the USB interface, right? So this converter is actually going to convert the data which is available on TX pin or on the UART interface. So it's going to convert that data, and it's going to send that data over the USB interface. Okay, that's why it is also called as USB to UART bridge. Okay, so it's basically a bridge between the two different protocols or two different interfaces, which is USB interface and UART interface. Okay, that's why it is called as USB to UART bridge. Okay, it's acting as a bridge between two different interfaces. So controller is going to send the data, which is actually the hello world, and we are going to see that data on the terminal. So that's basically the simple setup to send the data from the controller to the computer. Okay. And with this method, we are actually testing the controller whether it's working perfectly fine or not. Okay. So if we get the data on the computer or on the terminal, it means that the controller is working perfectly fine. All right. So that was basically the first setup. Then now let's see the second setup. So the second setup actually includes the DSO and our hardware. Okay. And I don't have this particular DSO. I have DS1102. So this DSO has got 4 channels: channel 1, channel 2, channel 3, channel 4. I just have 2 channels. Okay. So just for the image, I have included this particular DSO here. So again, we are going to do the same thing. We are actually going to monitor this TX pin of our controller, and we are going to connect this TX pin to the first channel. Okay. So to the positive terminal of this channel, we are actually going to connect this debug TX pin, and then the negative terminal of this channel will be connected, or negative or ground, which is basically the reference point. So this ground terminal of this first channel will be connected to the ground terminal of our hardware. That means here. And we are going to monitor the data which is sent by the controller over TX line on the DSO. Okay. So we will see how exactly the data corresponding to the hello world look like on the DSO. Okay. So that's basically the second setup. Now let me show you the demonstration for both the setups. So you can see here, this is basically the USB to UART converter, and I have connected 4 wires of this USB to UART converter to this hardware, or to our hardware. But out of all these 4 wires, we just need 2 wires. The first one is black, which is connected to the ground of our hardware and this USB to TTL converter, and another wire is yellow wire, which is actually connected to the TX pin on the hardware, and this yellow wire is connected to the RX pin of this USB to UART converter. Okay. Now what I'm going to do, I'm going to connect this cable. I hope that it's visible. So I'm going to connect this particular cable now at this point like this. Okay. So we have connected this cable now, and now let's program the code in the microcontroller. So you already know we are actually going to program the code of hello world in the microcontroller. So this is basically the same code that you can see here. So I'm going to program this code. I'm not going to explain you the code. We have already discussed. This particular training is completely dedicated to the hardware. So we are going to focus on that only. So you can explore this code later. So let me program this code in this microcontroller now. So you just have to click on this particular button, which is actually going to load the code in this controller. So you will find that these LEDs are actually blinking right now. It means that the code is now programmed in this controller. So whenever these 2 LEDs will blink, it actually means that the system is actually getting programmed. Okay. So I will show you one more time. So you just observe these 2 LEDs. So now you just observe these 2 LEDs. You will find that these 2 LEDs will start blinking as soon as computer will start programming this controller. Okay. So I'm going to press this button one more time, and you just observe these 2 LEDs now. So you can see they are blinking. It means that the code was programmed in this controller. So whenever the computer will program the code, these two LED will blink. Okay, I hope that that's clear now. So let me bring back the view. Alright, so the code is now programmed in this controller, and this controller is actually sending the data over the TX line or TX pin of UART interface. And in order to see that data, we have to click on the serial monitor icon on the Arduino IDE. So this is basically the serial monitor icon on the Arduino IDE. So I'm just going to click on this one, and you can see we are actually getting the data which is hello world on the serial monitor. So this controller is actually sending hello world data, and along with hello world, it's actually sending the carriage return and line feed. So it means that it's sending the carriage return, along with that a line feed means enter. Okay, that's the reason you are able to see the hello world in the next line. Okay, so that's how basically the controller sends the data on the serial monitor, and with that we have tested the controller and we found that everything with the controller is working perfectly fine. Okay, so I hope that this particular explanation related to how exactly the controller sends the data to the serial monitor is clear to you. And also, if you observe this particular LED, you will find that this LED is going to blink every time the controller is going to send the data, okay, on the serial terminal. Okay, so you just observe this particular LED, you will find that this LED is blinking. Okay. Alright, so that was all about how to send the data from the TX pin of UART interface to the computer. Now, what we are going to do, we are going to monitor the TX pin, and we are going to see how exactly that data or that signal which is sent over TX pin look like on the DSO. Okay. So for that, I'm going to use these probes, and this is how basically the DSO's probe look like. And I'm going to connect this ground terminal of DSO or the first channel of DSO to this terminal, which is basically the ground terminal. And another terminal I'm going to connect to this RX pin, which is basically the RX pin of this USB to UART converter. And the TX pin of the controller is connected to this particular pin. So I will connect properly here so that I won't short any other pin. Alright, so we are done with the connection now. Let's observe how exactly the data sent over this TX line look like on the DSO. So on the DSO screen, you can see in between we are actually getting the data. So just observe the screen. So you can see we got the data in between. So for that, first of all, I'm going to increase the time per division. Right now the time per division is 200 microsecond. So I'm going to increase it to 1 second. So let me increase it to 1 second. Then we will be able to observe the frame. So yeah, we got the frame. So whenever I will get the frame, I will just stop the DSO. Alright, so we got the frame now, and let me zoom at this point. So you can see we got the frame, and DSO actually have decoded this particular frame, and you can see hello world is written here. This is hello, then space WORLD, then carriage return and line feed is there. So this DSO actually have the functionality to decode the protocol. It can actually decode multiple protocols like RS-232 protocol, then SPI protocol, I2C protocol. So you can see here it is actually able to decode 4 different protocols. So this is serial protocol. Sorry, so I have to select the RS-232 here, and after that I will select this one. So this DSO is actually able to decode multiple protocol, and this is actually the serial protocol, and that's the reason this DSO has decoded it. And you can see on the DSO we are getting the data HELLO, then this is space WORLD, then /R and /N. I will just zoom this part, and just let me move this signal. And this is basically, so you can see hello space world, and after that carriage return and line feed is there on that side. So just a second. All right, let me move it now. So you can see WORLD, then carriage return and line feed. So these are 2 extra characters which are sent after the world character, world word. and let me bring this signal, and let's see the first character, which is L, and let's observe the H character. So let's see how exactly the H character look like. And we know that the hexadecimal value of H character is basically 48, right? Hexadecimal value of H character is 48. So if we convert 48 to binary, then its equivalent is going to be 01001000. Okay. So from here the data is starting, or the signal is starting for the H character. So this is actually 0, 1. Then there are actually 2 0 here, 0 0. Then again 1, and after that there are actually 3 zeros here. Okay. So 0 1 0 0 1 0 0 0. And this is basically the start bit of this protocol. And then again this is basically the stop bit. So that's how basically the H character look like. In the same way, the same thing is valid for E character also. It's going to have some hexadecimal value. So this is basically the hexadecimal representation of this E character. So this is how basically the signal look like, which is sent over the TX pin of UART interface. So I hope that from this you got a more clarity about how exactly the controller is sending the data over the TX pin of UART interface. Alright, so now let's discuss the mistakes that you should avoid when you deal with the microcontroller section. Okay. So the first mistake that you should avoid while dealing with the microcontroller section is orientation of IC. So when you solder the IC on the PCB, you have to make sure that you are soldering the IC in the right orientation. I have actually done this particular mistake, multiple times when I was getting started. So that's why I'm emphasizing on this fact that you have to solder the IC in right orientation. You know that the first pin, which is on the left hand side of the notch, it's basically the pin number 1. So this is actually the pin number 1, and you have to match the pin number 1 of the IC to the pad number 1 on the PCB. Okay. So always remember, you have to solder the IC in the right orientation. Then the second mistake that you should avoid is, even after soldering the controller on the PCB, it might happen that the controller will not work properly. And this actually happens because of, dry soldering of the pins which are connected to the PCB. So in that case, what you can do the touch-ups, okay, on all the pins, and that will actually resolve the, issue related to dry solder. So in such situation, you just have to make sure that you have to do the touch-ups all around or on all the pins of the IC, and that will resolve, dry solder related issue. So that's basically the second point. Then the third point is, while programming the controller from the Arduino IDE, you may forget to connect this 0.1 microfarad capacitor, okay, on the reset line, okay. So I told you that we need to connect this 0.1 microfarad capacitor between the DTR pin and reset pin. So sometimes it might happen that you may forget this capacitor. Now that we have actually placed this particular capacitor on the PCB, many people actually connect this capacitor, on the DTR pin, okay, on the DTR pin or external to the hardware. But placing it on the hardware is basically the right choice. So this actually will avoid the, the mistake to forget the 0.1 microfarad capacitor. So always make sure when you are programming the hardware, this 0.1 microfarad capacitor should always be there. Otherwise, the USB to TTL converter, it won't be able to reset the controller. So that was actually the second point that you should always, third point that you should always remember. After that, the fourth mistake that you should avoid is, once you have programmed the bootloader in the controller, once you have programmed the fuse bytes in the controller, you have to make sure that you have to connect this 16 megahertz crystal or external crystal to the crystal pins of the microcontroller. Otherwise, the controller will not work properly, or it will not boot up. So connecting this 16 megahertz crystal or external crystal is actually very important, because while programming the fuse bytes, we have told this particular controller that you have to use the external crystal as a clock source. Okay. And if we don't connect this, 16 megahertz crystal, then this microcontroller is actually going to keep looking for the external clock source. But as this clock source is not available, so it will not go ahead. Okay. It will not boot up. So this is basically the fourth mistake that you should avoid once you have programmed once you have programmed the bootloader in the microcontroller, once you have programmed the fuse bytes in the microcontroller, it's important or it's mandatory to connect the external crystal, okay, to the microcontroller. Otherwise, the controller will not work, okay. Alright, so that was all about the microcontroller section. We have discussed every single thing regarding the microcontroller section. I showed you how to test and troubleshoot the microcontroller section. Then we saw how exactly the controller is sending the data over the TX pin of UART interface. And after that, I also explained you the mistakes, 4 mistakes that you should avoid when you deal with the microcontroller section, okay. Alright, so that's what I wanted to tell in this video. I hope that every single thing that we discussed in this video is now clear to you. And if you still have any kind of doubt related to any part of this video, then definitely you can ask me and I will help you with that, okay. Alright, so now I will see you in the next video, which is about testing RGB LED section. So I will see you in the next video now.